Hello students, today we are going to discuss calculation involving concentrations of solution. And when I say concentration of solution, this also includes titration calculation. Concentration of solution has two formulas. Concentration of solution has two formulas. Concentration can be measured in mole per dm cube, in mole per dm cube, and it can be measured in grams per dm cube. And it can be measured in gram per dm cube. Concentration in mole per dm cube is what you are going to be using more. Is equal to number of mole n divided by volume in dm cube. Number of mole n divided by volume in dm cube. You have to convert your volume to dm cube. And concentration in gram per dm cube, as easy as ABC, as easy as it says it, is mass divided by volume in dm cube. Easy. Divided by volume in dm cube. So this is concentration in gram per dm cube. And how do I convert one to the other? Concentration in gram per dm cube equals to concentration in mole per dm cube multiplied by molar mass. Multiplied by molar mass. Concentration in gram per dm cube equals to concentration in mole per dm cube multiplied by molar mass. Now, before I give you any calculation on this, of course, I already have some calculations ready for you. Let me look at my page 1. And number 1 question says, convert the following 4.9 grams per dm cube of H2SO4 to mole per dm cube. 4.9 grams per dm cube of H2SO4 to mole per dm cube. This is easy. I already have my conversion. I have 4.9 grams per dm cube, 4.9 here, equals to, I don't know this, mole per dm cube, multiplied by molar mass of H2SO4. It's easy. It's just for you to add 2 times 2, 1 times 2, plus 32, plus 16 times 4, and this will give us 98. This will give us 98. I have 64 plus 32, that is 96, plus 2, that is 98. So you can do that yourself from your 4-figure or periodic table. So I have 98 here. Now I have I have 98 here. 98. Now I'm looking for mole per dm cube. So from here, mole per dm cube will be equal to 4.9 divided by 98. As easy as ABC. 4.9 divided by 98, and it gives us 0.05 mole per dm cube. 0.05 mole per dm cube, which is equal to 0.05 mole per dm cube. You can see how easy it is, as easy as ABC. So 4.9 gram per dm cube of H2SO4 is mole per dm cube multiplied by 98, and I'm looking for concentration in mole per dm cube. I bring 98 under this. If this multiplied by this is this, so this divided by that will be that. So I get that as easy as ABC. Very easy. It's not hard at all, not difficult at all. Now let's look at another one. 0.2 mole per dm cube sodium hydroxide to gram per dm cube. 0.2 mole gram per dm cube sodium hydroxide to gram per dm cube. Easy again, as easy as our ABC. Okay, I clean this again. I hope you have written it down. All right, we are saying 0.2 mole per dm cube sodium hydroxide. 0.2 mole per dm cube sodium hydroxide. So this is, again we go back to our formula, gram per dm cube equals to mole per dm cube multiplied by molar mass. So I have gram per dm cube already. No, this time around I have mole per dm cube. So I'm looking for concentration in gram per dm cube. 0.2 mole per dm cube. I'm looking for gram per dm cube. Mole per dm cube is 0.2. Molar mass of sodium hydroxide is 40, NaOH. This one is easy. It's 23 plus 16 plus 1. 23 plus 16 plus 1 is 40. That's 40 for us. Multiply by 40. So 0.2 multiplied by 40 I have 8 grams per dm cube. 8. My answer is 8 grams per dm cube. Easy or not easy? That means if I take 8 grams of solid sodium hydroxide and I have 1 liter, or what you call 1 dm cube of distilled water, and I pour 8 grams of sodium hydroxide, solid sodium hydroxide inside, of course it will dissolve. Mix it together, I will get this concentration 0.2 mole per dm cube. That is the meaning. That is the meaning. For me to get this concentration of sodium hydroxide, I have solid sodium hydroxide. I only need to weigh 8 grams of it and put it in 1 dm cube of water. That's what it means. You can see how easy it is. Let's continue. Now, let us now look at other calculations. Let's look at other calculations using our formula, using our big formula, that concentration in mole per dm cube. As I gave you before, concentration in mole per dm cube is equals to number of mole divided by volume in the m cube. The question says what? What mass of solid sodium carbonate is required to dissolve in 100 cm cube of distilled water to make a solution of concentration this? What mass of, we don't know the mass of sodium carbonate we are going to use. Mass of sodium carbonate, we don't know. Concentration that we are looking for. What concentration do we want? We want a concentration of 0.2 mole per dm cube. Concentration 0.2 mole per dm cube. What is the volume of the solution we want? We want 100 cm cube, which is the same thing as 100 divided by 1000, which is 0.1 dm cube. Easy. Now, I am looking for mass. For me to get mass, remember when I was teaching you mole, if I know number of mole, of course I will know the mass of the substance I'm looking for. Because remember, number of mole equals to given mass divided by molar mass. If I know mole, if I know the number of mole, and I know the molar mass, of course I know the molar mass because I'm giving the periodic table. So the mass will be easy for me to know, which I'm looking for here. And for me to know N, if I know N again, and this from my periodic table, I can know what I'm looking for. For me to know N, I can use this formula because I know the concentration, which is this, and I know the volume, which is this. From this formula, I can get N. Having got N from this formula, I will use that N in this formula. Just put it here. I'm looking for mass, I don't know mass, and I know MR. molar mass from my fourth periodic table. Easy. Then I get my mass I'm looking for. Easy or not easy? Can you see that? First, get your, you are looking for mass. You can use N equals to mass over molar mass. How can you get N? Get N from this formula, because you know this, you get your N. Having got N, then you get your molar mass from periodic table, get the mass you are looking for. Easy as A, B, and C. Even easier than that. Just know the formulas and move on. Now, first thing I want to do, I want to get my number of mole. Okay, I want to get my number of mole. So, concentration using this formula, which is 0.2 equals to N, which I'm looking for, volume 0.1. So, number of mole is easy for me now. I converted this to, of course you can see it, to dm cube, which was in cm cube. So from here, what do? Cross multiply. So N is equals to 0.2 multiplied by 0.1, which is equals to what? 0.2 multiplied by 0.1 equals to 0.02. 0.02 moles. This is the number of mole I have, 0.02 mole. I then use this in my next calculation. And which is number of mole I have equals to mass divided by molar mass. What is the molar mass of the substance? What substance are we talking about in that question? We are talking about sodium carbonate. What mass of sodium carbonate is required to dissolve in 100 cm cube of distilled water? So if you dissolve it in 100 cm cube of distilled water, the volume of the solution is still 100 cm cube. So to give you a concentration of this, we already know how many moles of sodium carbonate we are looking for. We already know how many moles of sodium carbonate we are looking for. Now, if we know how many moles of sodium carbonate we are looking for now, how can we get the mass of sodium carbonate we are looking for? Easy as A, B, C. Now, N 0.02 equals to mass that I'm looking for, and I don't know. What is the molar mass of sodium carbonate? Sodium carbonate. This is 23 times 2, that's sodium, plus 12, plus 16 multiplied by 3, that is 46 plus 12 plus 48. 46 plus 12 plus 48. 23 multiplied by 2 plus 12 plus 16 multiplied by 3, 106. Sodium carbonate 106. 106. This is 106. So I place that one here. You can see how I calculated that, which you know easily. 106. I put my 106 here. What am I looking for? I'm looking for mass. So I have 0.02 mass equals to 0.02 multiplied by 106. Easy. 0.02 multiplied by 106 equals to 2.12 grams. 2.12 grams. See? 2.12 grams. So in the question I've been asked what mass of solid sodium carbonate is required to dissolve in 100 cm cube of distilled water to give me 0.2 mole per dm cube of the solution. You know this is a soluble one. It's soluble. It's a soluble base. So now I take only 2.2 grams of sodium carbonate, and I dissolve it in 100 cm cube of water. I get what I'm looking for. I get a concentration of 0.2 mole per dm cube. Easy for you. It is easy for you to mix these chemicals in the lab. Just get your solid dart and mix it. Alright, let's go on. Let's look at another question. What mass of barium sulfate precipitate will be produced by adding excess barium chloride solution to 20 cm cube of 0.1 mole per dm cube copper sulfate? One thing I will tell you first, don't be scared. Don't be scared. Calm down. It is as easy as ABC. Please don't be scared. Calm down. Easy. What are they asking for? What mass of the precipitate will be formed? Of course, this is a precipitation reaction. This is our precipitate. You need the mass of this that will be formed. Look at the equation first. If it's a balanced equation. Is this equation a balanced equation? I have one barium here, I have one there. I have two chlorine there, I have two chlorine there. I have one copper here, I have one copper there. I have one sulfur here, I have one sulfur there. I have 4 oxygen here, and I have 4 oxygen there. It is a balanced equation. If it is not balanced, the first job you have to do is to balance your equation. Now you have balanced the equation. Now, what are you interested in? You are looking for barium sulfate. So you are interested in barium sulfate. What are you given? You have been given 20 cm cube of this concentration, 0.1 mole per dm cube of copper sulfate. You are interested in only these 2 species. You are interested in only these 2 species. And these 2 species, what is their ratio? This one is 1. And this one, nothing here, and it is 1. X and 1x means the same thing in mathematics, as I told you earlier. Now, 1 to 1, ratio 1 to 1. So the volume, the mole from the natural equation, the way it is created, the equation is created, is ratio 1 to 1. If it is ratio 1 to 1, now, what is the mole in my experiment? The mole in my experiment will also come ratio 1 to 1. So, the mole of copper sulfate I get will also be equal to the mole of barium sulfate I get. It's becoming easy now. I'm looking for mass. If I know mole, I can know mass. Remember, if I know mole, I can know mass. If I know mole, I can know mass. Remember that? So, I can get this from the periodic table, and I can know my mass easily. So, let us now look at it again. Now, I'm only interested in getting this. But what do I have to get it? I have this information about this. So, I do not have anything to do with this and this. So, I have 20 cm cube of this mole per dm cube of copper sulfate. So, now first let me get the mole of copper sulfate, because 1 mole of copper sulfate gives 1 mole of barium sulfate according to the equation, ratio 1 to 1. So, anything I get here for the mole of copper sulfate will be the same thing as the mole of barium sulfate. And it's easy for me to get the mole of copper sulfate here because I have the concentration and I have the volume. How is it? Now, getting the mole of this, I know concentration again equals to mole divided by volume in dm cube. Equals to mole divided by volume in dm cube. That is to say, let me shift this up. That is to say, concentration that I'm giving is 0.1. 0.1 equals to, I want to know the number of mole, because the number of mole, since it's ratio 1 to 1, the number of mole I get here is the number of mole of barium sulfate. So volume is, the volume is 100 cm cube, which is equals to 100 divided by 1000. 100 divided by 1000, which is equals to 0.1 dm cube, which is 0.1 dm cube. So I put 0.1 here. So for me to get my number of moles now, it becomes handy. It becomes handy, it becomes easy. N equals to what? 0.1 multiplied by 0.1, which is equals to 0.01. 0.01 mole mole. 0.01 mole. So I now get the number of mole of copper sulfate. As I told you, the way God created it is that 1 mole of copper sulfate reacting with 1 mole of barium chloride will give 1 mole of copper chloride and 1 mole of barium sulfate. So 1 to 1. So if this one is 0.01, this also has to be 0.01. As easy as A, B, C. So the number of mole of my barium sulfate is also 0.01. So the number of mole of my barium sulfate is also 0.01. So N of BaSO4 equals to 0.01 mole. So now I know the mole of barium sulfate. Easy for me now. Every other thing becomes easy. Now I know the number of mole. If I know the number of mole, and what am I looking for? Mass of barium sulfate, don't forget, is equals to mass, which I don't know, divided by molar mass, which I can easily get from my periodic table. I have one before me here. In my periodic table, barium is 137. So barium sulfate, Mr, equals to barium 137 plus sulfur 32 plus oxygen 16 times 4, 64. So 137 plus 32 plus 64 equals to 233. I got 233 here. 233 as my Mr. Now I use that formula that our friend there, N, which I know to be 0.01, equals to mass, which I'm looking for, divided by 233. Cross multiplying, I have mass to be equals to 0.01 multiplied by 233. 1212, which is equals to 2.33 grams. I am going to make 2.33 grams of barium sulfate precipitate. Easy or not easy? Just get your equation balanced. Concern yourself with only the things we are giving and the thing you are looking for. Okay, you are looking for mass of barium sulfate. If you know the mole of barium sulfate, you can know the mass. How do you know the mole? Since it is ratio 1 here to 1, so ratio 1 to 1, barium sulfate is 1 and this is 1. From that, if you get from here now, you can get the mole. Every 1 mole of this will give 1 mole of this. So X mole of this will give X mole of this. 1 million mole of this will give 1 million mole of this. 0.1 mole of this will give you 0.1 mole of this, as far as this equation is concerned. Now, how can you get the mole of this? You have the volume and you have the concentration. You can say concentration is equals to number of mole divided by volume in dm cube. I convert the volume to dm cube. I got 0.1 dm cube. So concentration 0.1 equals to number of mole, which I'm looking for, divided by volume, which I got here. When I cross multiply, I got my number of mole to be 0.01. If this is 0.01, this must also be 0.01. So N of barium sulfate, number of mole of barium sulfate, is also 0.01 mole. So N, using this formula, N equals to mass divided by molar mass. 0.01 equals to M divided by molar mass of barium sulfate. I calculated it to be 233, and I got my M to be 2.33 grams. Easy or not easy? Easy as ABC. Now let's look at other formulas. This one involves a neutralization reaction. This one involves a neutralization reaction, which is something that you get in your titration, but this one is not titration. But if you understand this, you understand all titration calculations. Same thing. Now I have what mass of calcium carbonate is required to completely neutralize 25 cm cube of these HCl. I have balanced the equation for you. And what am I interested in? What am I looking for? I am looking for how much of this we neutralize this. Because this is a base and this is an acid. The base is an acid. How much of this we neutralize this? So, what do? Now, I know that their ratio is 1 to 2. Every 1 mole of calcium carbonate I have, I must have 2 moles of HCl in this reaction. If I have 1 million mole of this, I must have 2 million moles of this. So, what do I have now? What am I looking for? I'm looking for mass of this. If I'm looking for mass of this, if I know the mole of this from N equals to mass divided by molar mass, I can know the mass. Because if I know this one from periodic table, I can know the mass by cross multiplying. That is easy as ABC. Now, if I now know the number of mole, for me to know the number of mole of this now, what do I have? I don't have anything from this to know the number of mole. But if I know the number of mole of this, it's a matter of dividing it by 2. Then I know the number of mole of this. Easy. If I know the number of mole of this, I divide it by 2, then I know the number of mole of this. Do I have enough information to know the number of mole of HCl? Yes. I have 25 cm cube as volume, and I have the concentration. Using my formula again for my HCl, I have concentration equals to number of mole divided by volume in the cube. So my volume is 25. I convert 1 to dm cube first. 25 divided by 1000, which is 0.025 dm cube. So I can now go that my concentration, which is 2, equals to n, which I don't know, divided by 0.025. I cross multiply again. I'm using this method, mathematical method, a lot, which is good for me. N will be what? N number of mole will be equals to 2 multiplied by 0.025, which is my 0.05 mole. 0.05 mole. 2 times 0.025 multiplied by 2 equals to 0.05 moles. 0.05 moles. I have 0.05 moles of this. Therefore, how much of this will I have? I'll forfeit. If I have 0.05 mole of this, in the natural equation is 1 to 2. So in my experiment, so if I get the number of mole of this, I divide it by 2 and I get this. Clear? Good. Now get for calcium carbonate, N for calcium carbonate is equals to 0.05 divided by 2, which is equals to 0.025 moles. Now this is N for calcium carbonate. And what am I looking for? I am looking for mass. Of course, I go back to the simple formula N equals to given mass, which I'm looking for, divided by molar mass. I know N, my N is 0. My N is 0.025 equals to the M I'm looking for divided by molar mass of calcium carbonate. What is the molar mass? Calcium is 40 plus 12, that is 52, plus Oxygen is 16 multiplied by 3, 48, 52 plus 48, 100. 100. So what do I do now? Cross multiply. Cross multiply. Write this down before I clean it. So I have N equals to M divided by MR. So 0.025 equals to M divided by 100. M equals to 100 divided by 0.025. This is equals to 2.5 grams. 2.5 grams. If I have 2.5 grams of calcium carbonate and I add it to 25 cm cube of what concentration of HCl? 2.0 mole per dm cube. I will be able to neutralize the acid completely just by putting 2.5 grams of calcium carbonate. Easy as ABC. Now, I now have a titration calculation for you here. Determine the concentration of 20 cm cube of nitric acid, which completely neutralizes 25 cm cube of 0.1 mole per dm cube sodium hydroxide solution. I have these in my burette, and I do not know the concentration. And I have these in my pipetted 25 cm cube of a known concentration of sodium hydroxide. I pipetted it, I taught you the other day, titration, and I drop it into my conical flask. Then I added my indicator. What indicator will you use now? I taught you the choice of indicator. This is a strong acid, you know that, and this is a strong alkaline, you know that. What indicator will you use? Any indicator. Strong acid, strong alkaline, any indicator. Remember that. So drop 2 or 3 drops of indicator and start titrating. After titration, we found out that 20 cm cube of the acid in our burette is required to neutralize this. 25 cm cube, of course, your pipette will take 25 cm cube of 0.1 mole per dm cube sodium hydroxide. Now, how do you now get? Now you have neutralized it. The indicator has changed color. It changed color at 20 cm cube. Now, how do you now know the concentration of the acid you have used? So it is as easy as ABC. This is a titration calculation. You have your pipetted 25 cm cube of sodium hydroxide into your conical flask. You added 2 or 3 drops of your indicator. Again, I'm repeating this. Then you started titration. You added your acid. You fill your burette, and you started titration. Started swirling your conical flask and looking directly, putting your white tile under the flask to see the genuine color, the real color. At the point when the burette run up to 20 cm cube, then the color change. Then you stop titrating. Stop titrating, and you got the volume of acid which completely neutralizes these of sodium hydroxide. And you got it to be 20 cm cube. So how do you now, from this information, determine the concentration of HNO3? First thing you have to do is to balance your equation. Is my equation balanced? How many hydrogen? 1, 2. How many nitrogen? 1, 1. How many oxygen? 3, 4. 3, 4. And how many sodium? 1, 1. Balanced equation. So 1 mole of nitric acid will always react with 1 mole of sodium hydroxide to give 1 mole of sodium nitrate and 1 mole of liquid water. But I'm not interested in all other things there. I'm only interested in what I'm looking for here and what I am giving here. Other things, I forget about them. Now, how much of this do I have? If I have 1 mole of this, I have 1 mole of this. Is it easy for me to get the mole of this? There's nothing for me to use. This is the mole of this I want. If I can know the mole of this, I'm looking for the concentration of this. If I know its mole, I use concentration equals to mole divided by volume, because I know the volume. So I only need to know the number of mole for me to get the concentration. Is it easy for me to know the number of mole? Yes, it is easy. How easy it is? If I know the number of mole of this, equals to the number of mole of this, because they are ratio 1 to 1. So how do I know the number of mole of this? I have the concentration of this. I have its volume, which I will convert to dm3. And I have, so if I have the volume and the concentration, so I can get the number of mole, N. Easy. So let's do that. Concentration 0.1 equals to N, which I don't know, divided by volume 25 divided by 1000. (0.025), of course, 0.025. So I cross multiply again and know my number of mole. 0.025 times 0.1, that's 0.0025. 0.025 multiplied by 0.1 equals to 0.0025. I'm correct. 0.0025 and equals to 0.0025 moles. If I have 0.025 mole of sodium hydroxide that I've calculated, that means I have the same mole of this because they are 1 to 1. So that means I have the same of that because they are 1 to 1. So what do I do now? I calculate for that. So I now know N of HNO3 is also 0.0025 mole. So I now use the same formula I used here, which is concentration, which I don't know, which I'm looking for, equals to number of mole, which I know now, divided by volume, which I also know. So what is the number of mole? 0.0025. What is the volume now? Is the number of mole. The volume is 20 cm cube, which is the same thing as 1, 2, 3. 0.020. That is 20 divided by 1000. 20 divided by 1000. 0.02. 0.02. 0.02. If I now divide this one out, I will get the concentration of the unknown. The unknown concentration of sodium hydroxide of nitric acid, which is 0.0025 divided by 0.02. 0.125 mole per dm cube. 0.125 mole per dm cube. So what I'm looking for is 0.125. So my answer is 0.125 mole per dm cube. You need to copy down these 0.125 mole per dm cube. So the concentration of this is 0.125 mole per dm cube. Easy or not easy? As easy as ABC. You know the mole of this must be equal to the mole of this. So, and you have been given all the materials to know the mole of this. So, easy for you to know the mole of this. You know the mole of this with this and this, with the volume and the concentration. Then that mole is the same here because it's 1 to 1. If it was 2, you multiply by 2. If it was half, you divide by half. If it was 3, multiply by 3. But this time, 1 to 1. So that same mole, you use it here. Concentration equals to number of mole divided by volume. Volume has to be in dm cube. Volume is 20. You divide by 1000. You get 0.02. So the number of mole you should know, which equals to the number of mole of this divided by this, and you get your concentration. Easy as ABC. Let's look again. Is there any other one? There is no other calculation here. I know by now that you understand concentration of solutions. This is what you use. This is what you use. Other teachers and other books, you have different formulas, different styles, but this is the easiest style. So easy. Just know the mole ratio from your balanced equation. If you know the mole ratio, then everything becomes easy. You will always be given enough data to get the mole of one of the things involved. Once you get the mole of that, compare it to the mole you are looking for according to their ratio. If it is 1:1, then equals to the same mole. If it's 2:1, the mole you get for the first one, then the one, multiply by 2. If it's half, you divide by half, like that. With that mole, you can get whatever you are looking for. Students, as I told you earlier, this is an easy topic. Chemistry, if you have been following chemistry with me, you will know that chemistry is as easy as ABC at all levels. Easy, not hard at all, not difficult. Okay? Please solve your questions, and if you have any other doubt, do not hesitate. Do not hesitate to send me your email, and I will send you a custom-made video answering your question. Good day, and God bless.